Oh my God, there's so many people. Ironically, I got into tech to avoid talking to people, and that has gone quite wrong. So this is my first time talking at a con, so go easy on me. I want to talk about a whole bunch. Thank you. I'm going to talk about a lot of common issues that SOCs have in their SIEM environments, particularly around detections and detection engineering, and kind of putting into context what that actually means. So I'm Regan. I've been working in a SOC for the last 6 years, a company called InfoTrust, or some of you might know us as Interlock. We rebranded a while ago. I'm a senior security engineer over there, and I primarily work on Microsoft, but we also manage a whole bunch of different SIEMs, Splunk, CrowdStrike, Rapid7, all of those. This talk is not sponsored, by the way. I'm not going to shill any particular platform as part of that. I'm just going to talk about things in a generic way. So as part of those 6 years, I've also implemented a lot of SIEMs and migrated content between them, and I've deployed a whole bunch of detections in my time. So I'm going to talk about a whole bunch of different common issues, particularly working in a big SOC that has to manage a whole bunch of different SIEMs. You probably, if you've ever actually worked in a SOC, you'll probably know that managing one SIEM is complicated enough, let alone a whole bunch of different ones at the same time. So the challenges that kind of come from that situation is what led me down this track of actually beginning to invest in detection engineering and building out that as a full-time practice in our SOC. You know, questions like, how can we actually improve the way that we manage all of these detection rules? How do we give our SOC analysts consistent context every time they look at an alert? And the 3 a.m. question, which is, you know, if you're reading an alert at 3 a.m., can you actually understand what's going on? Do you have the resources available to you to investigate that fully? So a quick agenda. I'm going to, first of all, run through common issues and some basic sort of prerequisites that we need to get under control before we can start talking about implementing detection engineering properly, capital D, capital E detection engineering. Then I will actually define that in the context of a SOC, and then I'll give you some ways of actually implementing that in your SOC starting on Monday. Also, it occurs to me that there's a lot of acronyms in cybersecurity, so real quick refresher for those who maybe don't know. There's a SIEM, it's the place, it's SIEM, not SIM. It's the place where you put all of your security logs, mainly. Detection rule, alert, SIEM rule, analytics. I'm going to use those words completely interchangeably with no rhyme or reason, so I'm sorry about that. And then SOC, which is your Security Operations Center. Now, for me, that's a team of engineers and analysts, but in your organization, it could be just a handful of analysts. It could be one guy or girl that looks at alerts. But just know when I'm talking about SOC, I'm talking about the people that look at and manage the alerts, and also the leadership team behind that SOC. So, common issues in SOC environments, or the why. You know, why do we need to embrace detection engineering? So, for those of you who maybe haven't worked on a SIEM before in like any technical capacity, they are insane to manage. They're large, they're complicated, and the complexity scales significantly as the organization gets bigger and you put more data into it. You know, and this goes for the SaaS platforms as well. They'll try and say that they're less complicated, but in a lot of ways they're even more complicated. If you've ever worked with like log analytics, API, and Sentinel, it sucks. But you begin to onboard log data from all of your different platforms. You're talking to different stakeholders. You might have different compliance requirements. You've got to start balancing your retention and your costs and make difficult decisions about the type of data you're putting into your SIEM. And a very common issue when we come into new environments is that there's a lot of data that has little to no security value going in, usually at a high cost in a SaaS environment. You know, it should be for security use cases, and yet there's constantly data that is worthless and not being used. And so before you know it, your SIEM is filled with data of little value, is a black box of configurations that nobody really remembers doing, but vaguely remembers that it might have been important to somebody at some point. And then on top of this as well, it's very common that SOC teams are under-resourced and overburdened, particularly with alerts, but then also regular SecOps tasks in the business, which usually leaves little time for any sort of introspection. So the first overall issue I want to talk about is a lack of SIEM maintenance and visibility in general. I find that a lot of teams lack a deep understanding of the data that's being logged, which you really need to understand first before we can start to build context-aware detection rules. We also need to map the data that comes into the SIEM in order to begin that process as well. So this is your prompt on Monday. Go through all of your indexes, all of your source types, all of your tables, and start like actually mapping out what data is coming in from where and like what is it. The second common issue I want to talk about is something I like to call vibe-based detection engineering. It's kind of like vibe-based coding, but for managing your SIEM rules, in the sense that you are going to be making ad hoc rule changes. And also, just for the record, I see this in every single environment. So if you feel attacked by anything I'm about to say, don't. Everyone is doing it, probably even worse than you are. But people, vibe-based detection engineering, the hallmarks, modifying your detection rule every time there's a false positive, or you only ever disable or tune a rule when it starts to spam, basically. So constantly acting reactively. Also over-relying on vendor-provided detections as well, so just enabling everything that comes with the SIEM. Vendors are really cool. I want to shout out the Splunk team and the Elastic team for providing just tons of great rules, but it's a very common trap to fall in of seeing a bunch of cool stuff that you can turn on, turning them on, and then you just have thousands of alerts being generated every single day. You also run into issues of detections running against data that doesn't exist or isn't being passed correctly. So those have never, and will never trigger. You might have poor search performance because they're all running at the same time. You might have detections that are looking at old TTPs, so tactics, techniques, and procedures, things that might have been relevant to your organization in the past, but is no longer. So, clearly there is a need to incorporate some sort of threat modeling into this process, right? And similar to the SIEM data problem, mapping and documenting your SIEM rules is often non-existent as well. So usually analysts end up having to essentially vibe out whatever they need to investigate each time an alert comes through. If you've got different analysts, they're going to potentially come to different conclusions looking at the same alert. So we want to have good documentation, documented response plans for most of our SIEM rules. And all of these issues kind of compound together to create that killer combination of alert fatigue and burnout, which I don't even need to talk about why that can be bad. So how can we start getting out of vibe-based detection engineering? So like I've said before, as a quick summary, we need to document every single data source that's coming into our SIEM. We need to know how it comes in, how it's passed, and from where, and what the purpose is. And then we should be documenting that in a single knowledge space. That way you've got a single source of truth for what data the SOC can actually use in their investigations. If you don't have a centralized knowledge base, this is a good time to get one and agree on one, I think. Please don't use SharePoint. No comments there. This process will feel quite tedious. You're going to feel like you're wasting time writing a lot of documentation. I know it doesn't sound very sexy, especially compared to some of the other things people have been talking about today, but this is the nuts and bolts of running a SOC. There are tools that help a lot with this process as well, like Detect for mapping and adding deeper context to the data that you have, but we need to focus on fixing the process rather than adding in more tooling at this stage. We also need to pay attention to SOC metrics. So we need to know things like not just true and false positive closure rates, but we want to understand the mean time to triage, mean time to closure, all of that kind of thing. We need to know if a detection triggers every hour, but maybe it has never detected anything that's a true positive in the last 6 months. We want to know about those. Same for the inverse as well. If something's detecting stuff constantly, but has never found a true positive, we need to know about them as well. So we need to start to measure all of these metrics and then combine these stats to get a clear picture of how the SOC is currently doing. And this will be really useful over the next 3, 6, 12 months as we start to implement detection engineering and we want to measure how successful it is. So, actually defining what detection engineering is in the SOC. So once you've got a grip on those issues, we can now start to actually think about building a structured process around it. So I think there's a broad understanding around what detection engineering is, roughly, that it's kind of this like DevOps thing where you have Sigma rules and then you convert them into whatever SIEM you have, and then you test them with something like Atomic Red or Splunk Attack Range, and then you deploy it somehow. That is true, that it can involve those things later, but to implement it in a SOC properly, there's actually a lot more to the story, which is what I'm going to talk about. So I'm going to put a definition on screen that I'm not going to read through, but I'll let you read. It's from a company called Anvologic that does detection engineering, and it was written in collaboration with the SANS Institute, and I just think it's really good. So feel free to read that in your own pace. But in functional terms, detection engineering fundamentally involves applying software development practices to creating and managing detection rules. So just like you might imagine with DevOps, but non-technical, you can kind of picture the process, right? You can say, you know, you have a requirements gathering stage, then you would maybe move those detections into some sort of a design backlog, into development, then you might have a testing phase, whatever that looks like for your organization, and then you move them into deployment. And then you can kind of think of that CI/CD loop of user feedback as your SOC team, and the SOC metrics on the previous slide, constantly feeding tuning advice and demand for new detection content. So critically, true detection engineering, not the Vibe one, is about building and maintaining a robust detection capability. And so the definition continues on, which is where we are sort of really starting to cook with what detection engineering is, right? You know, it encourages organizations to build their own tailor-made, context-aware detections. So now we're starting to look at, you know, doing threat modeling, we're doing threat emulation, we're incorporating principles of threat hunting into the actual development process, so it becomes a sort of multidisciplinary practice, right? And then, you know, if you come back into the software development type of workflow, you know, whether you want to just go straight in with detection as code and build crazy pipelines, you can. But you can also just start off with a simple Kanban board. You know, fundamentally, it's a process issue. You know, by forcing your engineers or your analysts to use a particular workflow, whatever form that may be, we begin to solve some of those common SOC problems. You know, we have a consistent documentation baked into the development lifecycle. You know, you can implement change control, make sure that, you know, things are actually being documented properly and there's actually proper reasoning and testing before these rules hit your SIEM. If you do detection as code as well, you get that sort of like atomic configuration of every rule and version control, so you can see what was changed and when and why. And that kind of, all of that combines into sort of the key point that I really want you to take away from this, which is that in order for detection engineering to truly be successful, it needs to be a fusion center. So it needs to serve the broader purpose of fusing all of these different inputs together. Feeds from your cyber threat intelligence, right? Whether you've got something like Recorded Future or you just are reading the news, public and private research, your own internal threat modeling. You might have red or purple team engagements happening, which can all feed inputs into your detection engineering lifecycle around things that were detected and things that weren't. You will probably have internal stakeholders as well, so you'll have different line of business applications with their own attack surface that need to be accounted for. And you might even have incident response as well. If there's an incident, we need to know what was triggered. All of that should feed into CI/CD. And as you can tell, my top arrow did not survive the transition to Google Sheets, but just imagine it goes around like this. So we need to work closely with our SOC analysts as well. We need to understand their alert volume and their metrics, so another input. This way we'll actually have a data-driven methodology for actually tuning our rules. You know, we get out of that reactive process and we become proactive. And by constantly tuning and taking in that feedback proactively, we start to avoid burning out our analysts with constantly triaging the same thing over and over and over and raising false positives all the time. We need to focus on integrating with the rest of the business, so coming back into the point about stakeholders, we need to make sure we're collecting all of the right logs from those apps and the attack surface. And so when we start doing all of these things together, detection engineering becomes a kind of connective tissue between your SOC and the rest of the business. It goes from being this function that just builds and deploys detection rules into actually sort of a core pillar of security resilience in the organization, which I think is pretty cool. So that's what detection engineering in the context of a SOC is. How do we actually start to implement and measure the success of a detection engineering program? So this is called the Detection Engineering Behavior Maturity Model, or the DEBM. This was published by Elastic in November of last year. And as far as I know, it's the first framework for actually specifically measuring the success of your detection engineering function and the maturity. So it comes with quantitative and qualitative metrics. It gives you very well-defined goals to strive for in order to reach certain levels of maturity, which you can feed back to the leadership in your business to say, look, we're doing these things, these metrics have improved, this thing is working. It starts all the way with tier 0, which if you're doing anything in vibe-based detection engineering, you are at tier 0. Sorry. But that's okay. It's called foundational. We all have to start from somewhere. And then it progresses all the way up to tier 4, which at that point, it then kind of starts feeding into a self-improvement cycle. And if you're at tier 4, you are operating at insane levels of sophistication, which you probably won't reach in all fairness. But it's visualized here in a continuous cycle as well. But another thing that's cool about it is that you can actually pick and choose which metrics you want to improve on in a non-linear fashion. So if you have budget constraints or your organization just isn't that big or there isn't a huge appetite to invest in this, you can just pick and choose certain aspects from the framework to build maturity into. Some teams may not need a complicated detection as code setup. It literally might just be that Kanban board process going left to right. So I'll do a quick whirlwind summary of what some of these tiers of maturity look like. So tier 0, as I mentioned before, your vibe-based detection engineering, you have virtually no processes. So you're doing things like deploying rules ad hoc. There's very little planning. You might see something in the news and deploy it that day, which is cool, but there's no real threat modeling occurring there, really. Tier 1, basic. So if you implement the things that we talked about at the beginning of this talk, you should find yourself pretty close to tier 1, if not achieving it already. So tier 1 involves actually having a defined rule set. So you have documentation for each of your SIEM rules. You have all of your data sources recorded, written down. You know what they are. And you've got maybe in the ballpark of 5 to 10 rules for each one of those data sources. You also want to have a decent coverage across all of those detections across MITRE as well. So you want to, for each application and each data source, you want to have detections that kind of represent at least a tactic in the kill chain. So that's really good. You also want to have version control at this point as well, either through detection as code or through your documentation knowledge base. Tier 2 is all about gap analysis. So this is really all about threat modeling. It's all about recording not just your SOC metrics, but your SIEM metrics as well. So we actually want to understand, okay, our SOC is doing well, we've got these metrics, but how are our detection rules actually performing? Do we have alerts that are regularly skipping? Do we have, are we dropping results? All that kind of thing. So that is kind of when you start to really begin to focus in on the nitty-gritty details. And then tier 3 and 4 is absolutely wild. It's the high end. So you are at this point, you should be doing regular threat emulation exercises. You should be doing automated testing via, atomic red team tests or Splunk attack range, whatever tool exists to do that you can use. You should probably be red teaming or purple teaming your environment and your SIEM rules regularly when you're operating at this kind of level of sophistication. You need to be integrating with CTI specifically in some fashion. And Tier 4 specifically also does call out that you should be delivering your detections into the SIEM via some sort of automated process. So in order to really reach that level of sophistication, they do kind of call for that detection as code setup, which for a lot of teams you don't need to worry about initially, but it is something to kind of strive for, leveraging projects like Sigma and all of that kind of thing as well. And you should be using SAW at this step as well. People love to talk about SAW, using SAW, and then they're all the way at Tier 0. You need to be pretty advanced to be using SAW. Anyone who's implemented SAW needs to know, in order for SAW to work, you need to have well-defined detection rules that are reasonably well-tuned. You need to have response plans already made before you implement the SAW, because you can't really do one without the other one, even though lots of companies try. But SAW comes in way at the end as well, traditionally here. So something that a lot of teams get caught up on, and what I'm going to kind of round off this talk with, is that we're technical people. We like to play with shiny tools, but detection engineering fundamentally is a process. It's a workflow. It's a discipline. It's documenting your rules consistently. It's documenting your data sources. And, it's very easy to get caught up in scripting crazy automated solutions. It's easy to get caught up in, converting and deploying Sigma rules and playing with atomic red teams, spinning up labs, spinning them down, spinning them back up again, just watching the Ansible tasks run. It's very fun, but that's not what detection engineering is all about. It's about the process. And you can achieve a huge amount of maturity in detection engineering just by building a process and sticking to it. So with all of that information in mind, I hope I've been able to give you a clearer understanding of what detection engineering looks like in the context of a SOC. And like I said before, if you implement any of the recommendations from before, you'll already be at Tier 1, which is something you can start doing on Monday. So there's really no excuse. Thank you very much.
Before Regan runs off stage, if you hadn't mentioned that was your first talk, I don't think anyone would have noticed. So I think an extra round of applause for your first talk here at CrikeyCon.
Thank you.